before we actually get started solving those equations, let's look at expanding out to get that form x squared plus bx plus c first, because we're going to need to go the other way. So if you were in class last week, we did this a little bit, but for those of you who weren't, let's have a look at expanding this. So remember that when we expand out these two brackets, we use a method that you might remember called FOIL, firsts, outsides, insides, and lasts. You might remember me saying earlier in the year, I don't love this acronym because it doesn't really matter what order you do it in. Okay, it just gives us a bit of a framework to follow. So everything in one bracket multiplied by everything in the other bracket. X times x is x squared, that's our firsts. Our outsides are x times 4, which is 4x. Insides negative 6 times x, which is negative 6x. And last, negative 6 times 4, which is negative 24. We're always going to end up with 4 terms, and oftentimes you're going to be able to combine those middle ones, collect some like terms. X squared and negative 24 can't be collected with anything else, but these middle ones here, plus 4x minus 6x is negative 2x, which goes in the middle there. Yep. So you'll notice, and let me just get rid of some of these, you might notice that this negative 24, it's the constant. It comes from the constant multiplied by the constant, right? Negative 6 times 4. That's where we get that negative 24 from. And this negative 2x in the middle here just comes from the negative 6 plus 4. Right? Negative 6 plus 4 is negative 2x because those two middle terms get added together. And so that's what we need to think about when we are factoring. Okay, so recall your null factor law from the last couple of lessons. If a times b is 0, then either a is 0 or b is 0, or they're both 0. These are the steps we've been following. So we're just going to follow those same steps, but with our Monic quadratic equations. Now up here, you'll notice that the name of the actual exercise in the book has this ax squared at the front. They're non-Monic quadratic equations. All of the questions listed in the work plan will be just Monic, so just x squared or potentially negative x squared. But if you get into the extension question, you'll be looking at some non-Monic quadratic equations. So just kind of ignore that for the minute. The first one we're looking at looks like this. So we remember, let me just get the right color. We remember that if we're going to get this x squared plus 7x plus 6, when we expand, then the factorized version is going to be two brackets multiplied together to get 0. Okay? To get this first term, this x squared, we need x times x. That's how we get that. And to get the last one, positive 6, that's a little bit trickier. To get a positive number, we need to multiply two positive numbers or two negative numbers, right? So the signs inside those brackets have to be the same. And what tells us that they're the same is this sign here, right? That plus tells us that when we add them, you get a positive 7, which means that they have to both be positive. Yep. So recall from earlier in the year, to factorize these, we use something called the cross method. Yep. And we put out our two x's that we're multiplying stuff by. We had our two arrows that overlapped, that crossed over each other. And remember that cross is important later when we look at this ax squared business. But just get into the habit of doing that. And then we have that positive 6, right? We need to get two numbers that multiply to give us positive 6. We could have 2 and 3, or we could have 1 and 6, right? Nothing else multiplies to give us positive 6. And what we want to do is we want to see which of these is the right one. Yep, so let's work with the first one. You might already be able to see it, but x times 6 gives us, x times 3, sorry, gives us 3x. X times 2 is 2x. When we add them together, we get 5x, which is not what we want, right? We want this positive 7x here. So that's not the right one. I'm just going to grab a red pen out and just scratch that out because that's not useful to us. Yep. Let's try the second one. We have x times 6, which is 6x, and x times 1, which is x. When we add those together, we get 7x, which is perfect. That's exactly what we want. All right, so let me get rid of all of this rubbish. We don't need that. the pair that we're after are these two pairs here, x plus 1, so I'll put that in here, x plus 1 and x plus 6. Now, if you're not convinced that that expands to give you what we started with, then just pause the video and go back and expand it up and just make sure that you get x squared plus 7x plus 6. But we've done step 1, right? We've factorized the equation. Our step 2 is to use the null factor law. We know that if we've got two things multiplied together to get 0, then either the first one is 0, the second one is 0, and then we just solve these. Step 3, solve the individual equations. X is -1 or x is -6. And then step 4 is state your solution. So therefore x is equal to, we want to put the smallest number first, right? So -6 or -1. Okay. Last step is to check. And again, when you start off with the first couple that you do, it's good to check just to make sure that it's working. So remember, we've got two solutions here. We want to substitute both of them in just to make sure they both work. So if we do -6 first, that's the kind of, it's going to have the bigger numbers. We have our left-hand side is x squared, so -6 squared plus 7x plus 6. And we're hoping that that equals 0. And I can't see it quite yet, but -6 squared is positive 36. Positive 7 times -6 is -42, and then plus 6. I can see it now. 36 plus 6 is 42. So we get 0, which is our right-hand side. So our first solution works, right? Our -6 works. Let's just quickly check that other one works as well. So we want -1 to work. Left-hand side is -1 squared plus 7 times -1 plus 6. -1 squared is +1. This is -6. Second example. This one looks a little bit different, right? But we still just have an x squared. There's no other coefficient at the front except a negative. So let's go ahead and rearrange this, because remember, again, with our null factor law, we want something times something to equal 0, and at the moment, we don't have it equal to 0, right? So we want to make it 0. I'm going to add 10 to both sides, and I'm going to get a -x squared plus 3x plus 10, add 10 to both sides, is equal to 0, right? That's going to cancel on the other side. Good, that looks more like what I want, but I still am not a big fan of this negative at the front. So I'm going to go through and multiply every single term by a -1, and that way I'm going to get rid of that first negative. Yeah, so I multiply the first term by -1. Remember, we're allowed to do anything to an equation as long as we do it to both sides, right? Any kind of legal mathematical operation. So that plus 3x will become a -3, will become a -10. And the 0, we'll flip the sign, it's still going to be 0, right? Multiply it by -1, nothing's going to change. Okay. Now it's looking good. Let's get our brackets out. We can factorize this now. If we have an x squared out the front, that means we've had an x times an x. If we have a -10 here, right, that's something times something equals -10. That means that it's a positive times a negative. That's the only way we can get a -10 out, right, a negative number. So we can go off to the side and do our cross method. We've got our x and our x and our crosses. Now, I want to know which number needs to be positive and which one needs to be negative. Yeah? Otherwise, we're going to have a lot more things to test that we don't need to test. And the way we're going to tell is we know that when we add those two numbers together, that plus that, we end up with a -3x. Right? That means the bigger number has to be the -1. Yeah? So going across to our cross method, we're thinking about what numbers multiply to give us -10. We have -10 and +1. Yeah. We have -5 and a +2, and that is it. Yeah. we don't have any other numbers that multiply to give us negative 10, where the sort of larger number is the negative 1. So let's go through and test them. Again, you might be able to see it already, but I go through and do it anyway. X times positive 1 is positive x. X times negative 10, negative 10. Add them together. X minus 10 is x minus 10x is negative 9x, which is not what we want. Right? We want negative 3x. So that one's no good. We don't want that one. I'm just going to scratch it out. Yep. Let's have a look at our second one, which hopefully is the right one because we've only got one left. Yep. X times positive 2 is positive 2x. X times negative 5 is negative 5x. We add them together. 2 subtract 5 is negative 3x, which is exactly what we want. Yep. Again, I'm just going to get rid of all of this and just circle the pairs that we want. What we want is x minus 5. The signs are really important here. And x plus 2. So x plus 2, x minus 5. Again, if you're not convinced, just go off to the side, expand it back out, and make sure you get what we started with. But our check will sort that out. Right? Okay, so we've factorized the equation. It's taken quite a while. We're going to equate each factor to 0, so we know that either x plus 2 is 0 or x subtract 5 is 0, which means that x is negative 2 or x is positive 5. Yep. Step 4, state your solution, negative 2. Okay, again, we're just going to do a quick check. So I'm going to go off to the side here and do a check and sub both of those values in. So we've got x is negative 2. Let's do that one first. The left-hand side. And we're going to use the left-hand side of the original equation and try and get that to be the right-hand side of the original equation. Just so we know, like the original equation is what we need to check, not something that we've transposed, because we could have done the part wrong. Okay? So left-hand side is negative x squared plus 3x. Negative x squared plus 3 times x. Be careful here, this is negative and then whatever squared, right? So negative 2 squared is positive 4. And this over here, positive 3 times negative 2 is negative 6. Negative 4 subtract negative 6, I didn't need to write that, was negative 10, which is our right-hand side, and that one works. Okay, that's the one. Sub x equals 5 into the equation. And see that the left-hand side is, again, negative x squared plus 3x, so negative x squared plus 3x. And we get negative, do the square first, 5 squared is 25, and 3 times 5 is 15. Negative 25, again, didn't need to write that line.